Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 8 contests. On Tuesday we had the Code Forces round 485. As well on Friday we also had round 486. On Friday morning we had the start of the Code Chef Long Challenge. And in the afternoon we had from Hacker Earth the June Easy contest. On Saturday at noon we had round 2A from Top Coder for the TCO 18. On Saturday evening we had Leak Code Contest 87. And on Sunday we had from Hacker Rank the Hour Rank Contest 28. As well, for the first few days of the week, we had the last half of the Hacker Earth Maze Circuits contest. Taking a look at the top 10 leaderboards, the notable finishers we had were Tourist in the first place spot in the Code Forces round 45 contest, and for the Top Coder round 2A we had B Mary and Petra in first and third, and also XUDYH in ninth, who notably was the 2017 TCO winner. Looking at the next 4 contests, the notable finishes here were Yui in second place for the Leak Code contest, as well as John Cram and Natsugiri in 9th and 10th, respectively. And in the Hacker Rank contest, we had Gennady, aka Tourist, in first place and Yui in second. Due to Code Forces round 45, we had some changes in the overall top 10 for the Code Forces site. Most notably, Tourist is now ranked number 1 once again, pushing Petra down into second place, and we had 000 moving from 5th to 3rd, Fate Ice dropping from 2nd to 4th, and Silo Viale dropping from 3rd to 5th. In today's video, we're going to be covering the solution to problem 2 from Leak Code Contest 87 entitled Longest Mountain in Array. The problem states, let's call any contiguous subarray B of A a mountain if the following properties hold. The length of your subarray B is greater than or equal to 3, and there exists some elements in your subarray B such that the elements to the right of your ith element in your subarray B are increasing, strictly increasing up until that element, and the elements to the right of that element are strictly decreasing. And you need to have at least one element on the left and on the right that's strictly increasing or strictly decreasing. So we'll see this when we look at the visualization of some of the examples. So given an array A of integers, return the length of the longest mountain, and return 0 if there is no such mountain. And note that the length of our array will be at most 10 to the 5, and so will the values in that array. So let's take a look at the examples that Leak Code provided us with. So here are the 2 examples. In the first one, we have our input, which is just a list of integers. That is our array A, and the output is supposed to be 5. And the explanation is that the largest mountain is 14732. So note that 7 is the peak on our mountain, and the numbers to the left of that are strictly increasing up to this peak, and the numbers to the right are strictly decreasing from that point. And for our second input, we just have 3 2s, so there are no strictly increasing or decreasing sequences, so it's impossible to have a mountain. So we're going to focus on just the first example here, and if we have a visualization of these integers, it looks as follows. So this is basically what it looks like, and you can pretty clearly see that if we have to choose a mountain, it will be the 5 numbers or columns in the middle here. So note that there are a few other valid mountains. This is a valid mountain because it still has at least one increasing pair of integers. This is a valid mountain, this is a valid mountain, but all of those are not maximal. So the one that we want is this mountain here. So the way we're going to solve this problem is using 2-pass algorithms. So we've probably looked at some algorithms that have 1-pass or 2-pass solutions in the past, but this is another video. So what we're going to do here is we are going to do a single pass from the first element to the last element, and we are going to to store the number of increases that we have. And we're going to do the same backwards, and we're going to call each of these up and down. So you can see here, using these values, we're just going to loop through and we're going to check to see if the element at this position here is greater than the one before. If it's not, we don't do anything. But if it is, we're going to do a +1 to whatever the previous value is. So what we'll end up with is for each element, the number of integers leading up to it that are increasing. So in our first pass, we will identify this column, and this column as greater than the previous column. So we'll end up with 1, 2, because there's 2 in a row, and 1 for the values in our up array. And in our down array, we'll identify this column is greater than the one to the right of it, this column as well, and this column. So we'll end up with 1, 2, 1 for these elements. And using these two arrays, all we have to do is loop through, store a local variable called answer, and we are just going to check that if each of these values are non-zero, we add them together and add 1. And the reason we add 1 is because technically these arrays are counting the spaces in between, so the differences between these columns. So we need to add 1 in order to get the number of columns. So doing this, we'll end up taking the 2 and the 2 from this middle column, and when we add 1 to this, our answer will be 5. So using this algorithm, you'll be able to get a correct solution. So let's take a look at our code. So here is the C++ solution. It is a function that returns an integer and takes a vector of integers as its parameter, which is the list of integers representing our array A. The first thing we're going to do is initialize a variable n, which is going to be just the size of the array, and our answer, which we will initialize to 0. Then we are going to declare our vector of integers up and down to be initialized to the size of our array A. And then we are simply going to loop 3 times, once to initialize or set the values in our up array, once to do it in our down array, and a third time to go through and to calculate our answer. So you can see here that we are always leaving out one of the elements when we are setting up our down and up arrays, because we don't want to go out of bounds on our array. And for the down array, we are looking to the elements to the right using the plus, and we are looking at the elements to the left using the minus for our up array. And so once we've set these two arrays up, we just check, are each of the elements non-zero? If so, set the answer to be the maximum of the current answer so far, and up plus down plus 1. And so once you've done this, you can just return your answer. So the Java code looks very, very similar, just slightly different syntax for setting up our arrays. And the only real difference here is that in Java, there is no such thing as implicit conversions. So you can't just check to see if this is a non-zero value. You have to explicitly say that the integer is greater than 0, and this will be a Boolean. And so taking a look at our Python solution, slightly different, but the same idea, 3 loops, leaving out a couple elements so we don't go out of range, and then setting our answer in the final loop and just returning that. So the last thing to talk about is the time complexity, and for this problem, it will clearly be linear in the length of our array A. Taking a look at the contest happening next week, we probably have the least busy week since I've started this YouTube channel, with only 2 contests. We have the CodeChef June long challenge that continues to go on, and we also have, of course, the weekly Leak Code contest number 88 happening on Saturday evening. But other than that, no other contests. So I wouldn't be surprised if Codeforces announces a contest at some point, so make sure to check my Twitter for announcements about that if that happens.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.